This reaction, Grignard. Grignard, we got the ketone, we got the alcohol. So what do you think is going to happen? The first thing going to happen, you think the Grignard is going to make an attack to carbonyl and then kick it out. That's the first thing you think is going to happen, right? Because that's what everybody saw it. The first thing is going to happen is the Grignard taking this proton and then one reagent basically killed. That's something I've been telling you. Grignard is a strong base. And then proton or oxygen are acidic enough. So when the Grignard reduce that, it's gone. That does not mean that it's not going to work. You just have to use one more reagent of Grignard. So you need a full equivalent of Grignard. First one, you take this proton and they just dead. Second one, if you got enough, now that's the one that go attack here and then do these reactions. And then this negatively charged oxygen is going to be far away from that side, so that's not going to be matter in this case. If they are right next to each other, that may becomes a problem because it's the electron recursions between the negatively charged oxygen and Grignard, but they're far away, so it should be fine. So eventually, if you got enough Grignard, you can make it happen after this happens. You only have one equivalent of Grignard, you're not going to be this product. You're going to be just this and that. And then that will pick up the proton in the end. So you got that alcohol, stays on alcohol, but that one basically becomes an alcohol after alcohol in the body. So that's kind of another way you need to think about it. Some of the reactions that we discussed before is going to be combined together. Reaction in chapter 8, reaction in chapter 9, reaction in chapter 6, all these things now all come together. That's kind of the things what makes organic chemistry challenging. Its nature is cumulative. There's no way you cut away SN2 from any further reaction afterwards after chapter 6, right? So first reaction is that organolysis. You break them up, right? You break them up, and then organolysis make a doubly substituted side ketone, singly substituted side aldehyde. But you can treat the sodium borohydride afterwards, then it's going to reduce the ketone to the alcohol, then aldehyde to the primary alcohol, right? You know that. We teach you this, then what we do later is change the reagents. We do this permanganate in the sodium borohydride. Then what will be the product? Same. The permanganate can cleave the double bonds, oxidative cleavages. But it cleaves the doubly substituted side, becomes a ketone, singly substituted side, carboxylic acid. When you're using a sodium borohydride, carboxylic acid doesn't get reduced. So only the ketone get reduced, you get different products. So you really need to know what each reagent does.